How long does it take for a person to run if they run at 4.5 meters per second for a distance of 21 kilometers in the south direction? So let's solve this problem. Here we're looking for time. So I'm going to draw the scenario where we start at x1 equals 0 meters, and we're going to start at a time of t1 equals 0 seconds. Then the person runs this way, south direction, and finishes at a point x2, which is at 21 kilometers, where t2 is unknown. So we don't know what time they arrive at. So what we have is our average velocity formula is delta x over delta t, and now we want to solve for time. So we can multiply time over to the left side and then divide velocity over to the right side. And that gives us delta t is equal to delta x over our average velocity. And this is what we want to solve here. So the first thing I'm going to do is I am going to convert kilometers to meters because our velocity is in meters per second and we want our units to be the same. So 21 kilometers for every 1 kilometer, there's 1,000 meters. So 21 times 1,000, and we've got 21,000 meters, or 2.1 times 10 to the 4 meters in scientific notation. So that's delta x. And notice one thing, I'm going to leave this as delta t and delta x because since x1 and t1 are 0, delta t is just equal to t2, and delta x is just equal to x2. That only applies if the initial values are 0. So now all we have to do is plug in the numbers, where delta t is equal to 21,000 meters divided by 4.5 meters per second. So what happens here is with the units, because we got to make sure the units work out to a time unit, what happens is the meters are going to cancel out, and the seconds, since it's in the denominator of a denominator, so 4.5 is in the denominator, and the seconds, we're dividing by that, comes up to the top to give us a unit of seconds. And so the units check out, and delta t is 4.7 times 10 to the 3 seconds. Of course, time is not a vector, so we don't have to specify a direction here. And this is kind of hard to understand. We don't know really what 4.7 times 10 to the 3 or 4,700 seconds really looks like. So I'm going to convert this to hours. So I'll just do 4,700 seconds. So how many seconds in an hour? First, we can look at how many seconds are in a minute. So 1 second, sorry, 60 seconds in 1 minute. Okay, now we do the same thing. How many minutes are in an hour? There's 60 minutes in 1 hour. So what we're doing is taking 4,700 divided by 60 divided by 60, or 60 times 60 on the denominator. And so what we really get is that delta t is equal to 1.3 hours, or just over an hour and 15 minutes.